The responsibility of for maintenance and calibration rests entirely with the industrial laboratory itself. Secondary standards are generally sent to the National Standards Laboratory on a periodic basis for calibration and comparison against the primary standards. So then and there, the instruments are calibrated and it is updated to the National Standards Organization. And next, company instruments laboratory. There, they have to follow the working standards. Working standards are the principal tools of a measurement laboratory. They are used to check and calibrate general laboratory instruments for accuracy and performance, or to perform comparison measurements in industrial applications. A manufacturer of precision resistance, for example, may use a standard resistor in the quality control department of their plant to check his test equipment. In this case, the manufacturer verifies that his measurement setup performs within the required limits of accuracy. So that is the thing. So whatever may be the physical measurement, that has to come within the range or within the limit. So that is the working standard. And finally, it goes to or it is in process side or measurement side. So again, they need to check the process proper value, and the standard laboratory has to check whether it is above the second standard, and periodically they need to send it to the updated one to the primary reference standard developers, that is the National Standard Organization. So this is the instrument calibration chain. Next, how to record this test value or calibrated value. So there is a particular template you can see here, the typical format for instrument record sheet. There you can find type of instrument and company serial number, manufacturer's part number, manufacturer's serial number, and measurement limit, and date introduced, and the location, and instructions for how to use, and calibration frequency, and who is the responsible. That people, they need to put the sign, signature of responsible person, and the sheet has to contain the calibration record, that is the calibration date. Next, the calibration result, and calibrated, who is calibrated. So all these things should be recorded. And the first part, you can see that from type of instrument to calibration frequency, this will be like a nameplate. You can find any kind of instrument. But once if you goes, or if you want to check or calibrate the instrument, and all these things should be recorded. So this is about the instrument record sheet. The next one is types of standards. Particularly, we are going to discuss what is there in our syllabus. The first one is NEMA, that is the National Electrical Manufacturer Association. The next one is BIS, Bureau of Indian Standards. And third one is DIN, Dutch Institute for Normen, means German Institute for Standardization. And the last one is ANSI, American National Standards Institute. So these four standards we are going to discuss in this video lecture. The first one is NEMA, that is the National Electrical Manufacturer Association. So this is developed in US. Here it has 5 top standards. One is ANSI Z535, that is for safety signs, symbols, labels, and colors. So this first one is especially for safety signs, symbols, labels and colors. And second important one is NEMA MW1000. It is especially for defined magnet wire. And third one is NEMA 250, enclosures for electrical equipment. And fourth one is NEMA MG1, that is for motors and generators. And the next one is NEMA PB 1.1. This is for installation and proper operation and maintenance of panel boards, nearly rated as 600 volts or less. So these are top 5 standards by NEMA. And other new releases of NEMAs are, one is ANSI 78.81. It is developed in 2016. This is especially for electric lamps, double gapped fluorescent lamps, that is EFL. It gives the standards about the dimensional and electrical characteristics. The next new release is ANSI 84.1. That is about the electric power systems and equipment. The voltage rating is 60 Hz. And ANSI C119.4, that is also developed in 2016. This is especially for electric connectors for use between aluminum to aluminum and aluminum to copper conductors, and especially it is designed below 93 degrees Celsius, and copper to copper conductor designed for normal operation at or below 100 degrees Celsius. The next one is NEMA 107. This is for RIV, that is a radio influence voltage, particularly for high voltage apparatus. And NEMA SB10, this is especially for hospital side, particularly it is audio standard for nurse call systems. And NEMA SG AMI1, this is about smart meter upgradability. And next, NEMA WD7, again it is revamped to on 2016, particularly for motion sensors. And the last one, NTCIP, that is for transportation. So these are all new releases by NEMA. Here I'm going to explain some of the important electrical standard by NEMA. So the NEMA standard, the electrical frequency is 60 Hz current rating. If it is high voltage HV, that is equal or greater than 100 kVA, and equal to or less than 230 kV, kilovolt, that is the high volt. And if it is EHV, extra high voltage, means greater than the 230 kilovolt but less than the 1000 kilovolt. And if it is UHV, that means ultra high voltage in the sense, then it has to equal or greater than 1000 kilovolt. This is about the electrical standard by NEMA. Next, how it will be phase spacing and ground clearance. That means if I lay the cable, then that electrical cable, the phasing and the ground clearance, if it is for 230 kilovolt means, then the phase spacing should be 3.4 meter, that is 11 feet. Distance in the sense it should be 4.6 meter. If it is maximum, that is the 1100 kilovolt in the sense, the phase spacing between one line to another line, it is 16.8 meter, nearly 55 feet, and the ground clearance or distance from ground is 16.8 meter, it is nearly 55 feet. So you can check this table for if the voltage is this much range in the sense, then what is the space between the one line to another line? That means one phase to another phase and ground clearance. So this is by NEMA. So far we have discussed about the introduction about calibration and standards and calibration chain. We have discussed about the calibration record sheet, and the type of standard we discussed only National Electrical Manufacturer Association, and the remaining standards BIS, DIN, ANSI we are going to see in the next video lecture. Thanks for watching.